index n. This constant ratio sin I over sin r is known as the refractive index for two given media. Formula for reflective index n: 1. n is equal to sin I incidence over sin r refractive. 2. n refractive index is equal to real depth over apparent depth. 3. Refractive index n is equal to 1 over sin c critical, where c is the critical angle, thus the reciprocal of sine of a. Critical angle is the refractive index of two given media. 4. Reflective index is equal to velocity of light in vacuum over velocity of light in a medium. 5. Reflective index is equal to sin I reflective over sin r, which is equal to sin a plus in bracket a plus d all over 2 over sin a over 2, where d is angle of mean deviation, a angle of prism. Example 1. If the angle of incidence I on an air-water boundary is 60 degrees, calculate angle of fraction r, taking reflective index n to be 4 over 3. Solution: sin I over sin r is equal to sin 60 over sin r. N is equal to 4 over 3. Making sin r the subject of the formula, we now have 3 over 4 sin 60, which gives us 0.6495. Getting the sine inverse to get the refraction, we have 41 degrees approximately. Example 2. Water is poured into a jar to a depth of 24 cm. The bottom of jar appears to be raised by 4 cm when viewed vertically. Calculate the reflective index of water. Solution: apparent depth is equal to 24 minus 6, which is equal to 18 cm. Real depth is equal to 24 cm. Therefore, reflective index n is equal to real depth over apparent depth, which is equal to 24 over 18, which will give us 1.33. Example 3. If the refractive index of medium is square root of 2, what is the critical angle? Solution: reflective index n is equal to 1 over critical angle, where c is the critical angle. Therefore, square root of 2 is equal to 1 over sin c. Making sin c the subject of the formula, we have 1 over square root of 2. Sin c is equal to 1 over square root of 2, which is equal to 0.70710. Therefore, the sine inverse of 0.70710 is equal to c 45. The critical angle is 45. Alternatively, you can say sine incident over sine reflective is equal to reflective index. Critical angle is c over sine 90 refractive, which is equal to 1 over square root of 2. Sin c is equal to 1 times sine 90 degrees all over square root of 2, which is equal to 1 times 1 over square root of 2, which will give us 1 over square root of 2. Square root of 2 is 0.70710. Therefore, the sine inverse of 0.70710 is 45. C is 45. Example 4. If the critical angle from air to glass is 42 degrees, calculate the reflective index for the glass. Solution: since the reciprocal of sine of critical angle c is equal to the reflective index n of the two given media, we have that n is equal to 1 over sin c, but c is equal to 42 degrees. the reflective index A to gas is equal to 1 over sine 42, which will give us 1.5. Therefore, the reflective index air to gas is equals to 1.5. Example 5. The reflective index of a liquid is 1.5. If the velocity of light in the vacuum is 3.0 times 10 raised to the power 8 meters per second, what is the velocity of light in water? Solution. Reflective index n is equals to velocity of light in vacuum over velocity of light in a medium. That is 1.5 is equals to 3 times 10 raised to the power 8 over velocity of light in a medium. Velocity of light in medium is equals to 3 times 10 raised to the power 8 over 1.5, which is equals to 2 times 10 raised to the power 8 meters per second. Example 6. A ray of light experiences a minimum deviation when passing symmetrically through an equilateral triangle glass prism. Calculate the angle of incidence of the ray taking reflective index of glass equals to 1.5. Solution. Looking at the diagram, angle of reflection R is equals to 30 degrees. Sine I over sine R, sine incidence over sine refraction is equals to n. That is sine I incidence over sine R 30 degrees is equals to 1.5. Making sine I the subject of the formula, we have 1.5 sine 30, which will give us 0.75. Therefore, I is equals to sine inverse of 0.75, which will give us 45 degree 35 inches. Then the reflective index n is equals to sine I over sine R, which is equals to sine in bracket A plus D all over 2 over sine A over 2. Therefore, 2 sine I is equals to 1.5. Sine I is equals to 0.75. I is equals to 48 degrees 35 inches. Example: if 60 degree glass prism has a reflective index of 1.5, what is the angle of minimum deviation dm? Solution. Reflective index is equal to sine I over sine R, which is equal to sine in bracket A plus dm over 2 all over sine A over 2, which is equal to sine in bracket 60 plus dm over 2 all over sine 60 over 2, which is equal to sine in bracket 60 plus dm over 2 all over sine 30 degrees. 1.5 is equal to sine in bracket 60 degrees plus dm over all over 2 all over sine 30. By cross multiplying, we have that sine 60 plus dm over 2 is equal to 1.5 sine 30, which will give us 0.75. Taking sine to the other side, making this sine inverse of 0.75, we have 60 degree plus dm over 2 is equals to 49. Dm, making dm the subject of the formula, we now have 98 degree plus 60, which we now have that 8 degrees 655 inches. Reflection of light through lens. Lens formula: real is positive RP. Lens equation: 1 over u plus 1 over v is equals to 1 over f. Focal length f is positive for converging lens and it is negative for